card as shown as object as shown in figure 1.1. The object is placed at one end of a meter rule and the lens is fixed at distance u from the object as shown on figure 1.2. The slit is illuminated from behind using a lamp. A screen is then placed on the meter rule so that a sharp focused image of the arrow is formed. The distance d from the lens to the screen is then measured. Explain how the student ensures that the image is sharply focused on the screen.
So what is the answer of it?
Sir, we can move the screen forward and backward slowly.
So you are moving the screen. If you are moving the lens, what is the problem?
Uh, I don't think there's a problem.
Huh? If you move the lens, then what will be the problem?
The lens is fixed.
Lens is fixed somewhere. That's why you cannot move it. And the object is also fixed.
Placed at one end.
Okay. So you cannot move it. The lens you cannot move from there. That way it is fixed. And what about Abir? Abir, what did you write? This answer?
I wrote by moving and adjusting the screen.
By moving and adjusting the screen. Your answer is correct. Both of your answer is correct. And there is a reason why we are moving the screen. The reason is, for the lens there is focal length, right? Hello. When we will study the waves, the topic for the light, then we will get the application of lenses. And you will understand for different positions of the lens and the object, you will get the image in different ways. In our O level, we have three positions of the object. For these three positions, we are getting the image in three ways. The first position is the object is outside the double of focal length. Are you getting me what I'm saying? Hello? Tamjid and Abir, are you getting me what I'm saying? You got the
Yes, sir.
idea of lens in your school or anywhere.
Yes, sir.
So you know what is called focal length.
Yes, sir.
What is called focal length?
Sir, it's the distance from the from the center
To the
lens, the lens, like
so center of what?
the point at which, sir, my graph way te porchi to, so the point
So
at which
look,
the
what is
line.
called focal point? Focal point is the for a lens. For example, it is lens, right? So this lens has optical axis. I'm drawing bigger, then you'll understand it. Like here, I'm going down. Okay, here we have a space to show you. Like this one is your lens, okay? And in this lens, we have a point, what you said, center, right? That is called optical center. And this one is optical axis. And this one is principal axis. Both optical axis and principal axis are going through the optical center, but one is vertical, another one is horizontal. Is it clear? So in your note, in your worksheet, you draw it now. Label the way I'm doing. This is principal axis. And this is optical axis, the vertical one. And this one is optical center, the center one. So you can understand it, optical center. I'm writing here optical center. Label with O, optical center, O. Now, if we have some rays are coming from far away, those rays we are thinking or we are considering coming from far away are parallel to principal axis. These rays are coming parallel to principal axis. Okay, now these rays, after passing the lens, they will meet on a single point here on the lens. Sorry. Are you drawing? Hello? Amir? Kamjit, are you drawing?
Yes, sir.
So
Yes,
this
sir.
point where all these parallel rays are converging together, this point is called principal focus or focal point. Principal focus or focal point. Principal focus or focal point. Please take these notes. I will tell you to send me this diagram. Okay, so you take these notes. This point F is known as principal focus or focal length. So the point O, that is optical center, and principal focus, the distance we have, this is called focal length. And this focal length, and this way we can label from here to here. This distance is known as focal length. So you write here f is focal length. F is focal length. So you got it, focal length. What is called focal length? Now, if the object is staying close to the focal length, like this object, if it is very close to the focal length, that means less, very close to the lens, that means the distance of the object is less than the focal length from the lens, then there will be virtual image. You cannot show it on the screen. Is it clear to you? Hello?
Yes, sir.
That's why we are not moving the lens and the object. We are fixing it in a place so that it is in between the focal length and double of the focal length, so that our image we can show properly here, or at least more than double of the focal length. If you are keeping it in between f and 2f, then it will be working like a projector. Your image will be bigger size than the object size. But if you are keeping the uh, object in between, that means outside of the 2f, this distance is known as f, right? Do you understand what I'm saying? 2f?
Yes, sir. Double the focal length.
Yeah, double the focal length. Yes, I'm pointing that one. So if your object is more far than the double of focal length, then your image size will be smaller than the object. Here we see the image is a bit larger. Image is a bit larger than the object. Object is here, this whole. Okay, so we understand it that it's between f and 2f. Okay, is it clear why we need to fix it?
Yes,
The
sir.
lens and the object. Hello?
Yes, sir.
Yes. So we are done with this part. Whatever you wrote, that is correct. And beside your answer, you write slowly. You move your screen slowly, carefully. Now we are going to next part. This part is very easy, right? You have to just get the lengths, right? So what you got for you?
U is 6 centimeter and V is 4.3 centimeter.
Okay, then Tamjid, you got the same.
Yes, sir.
And what is your focal length?
2.5 centimeter.
Sir, 2.49. Yeah, 2.4.
2.49 centimeter. Okay, fine. 2.49 or 2.5, same thing. Yeah, one is two significant figure, another one is three significant figure. Then what is the answer of last part?
Sir, repeat and find the average.
Repeat and find the average. Okay. Uh, Suggest one way the student ensures that his value for f is accurate. Very good. So your answer is correct. Abir, you all also got the same?
Yes, sir. I wrote take measurement multiple times and average it.
Very good. Very good. Uh, then we are done with question 1. Now question 2 left, right? From here, all others are done. Then Can you read it, Abir, from here, from the beginning to? Hello?
A student carries out an experiment to find the mass of an meter rule. She uses a number of identical metal rings and a pivot. Each ring has a mass of 3.3 grams. The apparatus is set up as shown in figure 2.1. The student places the pivot under the 4.5 centimeter mark on the meter rule. She then places rings one at a time on the meter rule at a uh, point A 5 centimeter along the rule. She adjusts the number of rings until the rule is close as to balance as possible. She refers the number n of rings needed to balance the rule. The rings are circular with a central hole as shown in figure 2.2. Measure the outer diameter of the ring.
Okay, so you got the outer diameter?
Yes, sir. 2.2 centimeter.
2.2 centimeters. So how you got it? Did you measure it with
Yes,
your
sir.
ruler?
Yes.
Exactly you got 2.2 or you got less or more?
No, exactly 2.2.
What about Tamjit?
Ji sir.
You got, what is your answer?
Sir, question number 2 to kori nahi because it wasn't
Okay,
shown.
okay. Now you do the way I'm doing. You do this way. You make a center here, find the center here, and through this center you draw one line with your ruler uh, and pencil. Then check the length. That will give you the diameter.
Okay, sir.
Do it. Yeah, Abir, did you do this way? The way I'm showing. If you didn't do this way, now you do. You find a center here, then draw one line, then take the length of that line and get the answer.
Sir, 2.2.
2.2 centimeter. Okay, you got 2.2. Exactly 2.2.
Ji sir.
Okay. So we are going to now next one. Yeah, continue, Abir.
Figure 2.3 shows a section of the meter rule. On figure 2.3, draw one ring correctly placed at 5 centimeter mark. Explain why the student has the ring carefully one at a time.
So how we'll draw it here? You will draw in a way so that the center of the ring is going. See, I'm drawing here. Center of the ring should go through this 5 marked line. Okay, you see, this 5 marked line is going through the center. Is it clear? Hello?
Ji sir, Parji.
Done? And then continue, Avir, explain.
Explain why the student adds the rings carefully one at a time.
Yeah. So, what is your answer? You got your answer.
No, sir.
So think of, explain why the student adds the rings carefully.
Because sir, because uh, there may be a turning effect,
Say,
or the ruler
I'm
may fall
writing, I'm
down.
writing, I'm writing. You say and I'm writing. Number one, what you're saying,
Uh,
say,
there may be a turning effect, and the ruler may fall down, or
there might be a turning effect and the ruler might fall down or the masses might fall down.
এটা এটা কি মানে গ্রাউন্ডে করতেছে নাকি না সেটা জানি না। হ্যাঁ, the masses may fall down সেটা লেখা যাবে।
Masses may fall down. Look, the diagram at the beginning is given, right? How to balance it? You see how it is kept on a pivot, right? So you have to keep them here, and if you are not keeping them carefully, then they might fall down, right? Now you understand, Tamjid?
জি স্যার।
Okay, so it's little bit above the ground, the ruler, and it's on pivot. Then any more idea from Abir? You have any other idea?
Too much weight makes the weight uh, that thing fall down. The rings fall down.
Okay, I'm writing what you are saying. Say again.
Too much weight might make the rings fall down.
Too much weight might make the make the
Rings fall down.
rings fall down, right?
Yes.
Okay, so a similar idea, right? Fall
Yes.
down. Okay, fine. Your idea is correct. Both the ideas are correct and very similar ideas. Okay, now we are going to next one. Yeah, continue, Abir.
The distance L between the pivot and point A is changed by moving the pivot closer to A. The student repeats the experiment for a different value of L and draws a table of results as shown in figure 2.1. On figure 2.4 on page 7, draw a graph of M on the y-axis against L per centimeter on the x-axis. Start your axis from 0, 0. Draw the best fit curve.
So we are going to the curve. Okay, graph line. How to draw the graph? You see, our reading are given here. So L will be on x-axis. The range of L is from 0. They are saying to start the graph, to start the axis from 0, 0. So the range is from 0 to 40, right? And in your x-axis, you have 1, 2, 3, 4, 5, 6, 7, 8. So you can do it this way. Here we'll write 40. Okay. Here we'll give 40. And
Sir, on the y-axis, what will we label?
okay, x-axis, we are going there, y-axis. In x-axis, we are labeling L, right?
Yes.
L in centimeter,
Mm.
isn't it?
Yes.
And y-axis, we are giving number of rings, right?
Yes.
And
N.
it does not have any unit.
Yes.
It does not have any unit. This one I have to remove. Okay, so for the x-axis, you got the maximum range 40. So each of the two two small squares is giving you 10, right? Here 10, so you label here 10, then here 20, then here 30, then 40. Okay, done. This part is done, right? X-axis.
Yes, sir.
And the y-axis now will go. How will label y-axis? See, y-axis we have till 70, huh? From 0 to 70. So in y-axis, how many squares we have count? 1, 2, 3. I'm counting 1, 2, 3, 4, 5, 6, 7, 8. Again 8, right? Here also 8. Isn't it? Hello?
Sir, can we
Yes, sir.
use 10 small boxes for 1 centimeter?
Yes, yes, that one we are saying that each of the big square we will use at 10. Okay, here 10, then 20. This way we will go to 70.
No,
Okay,
sir, I'm saying about the x-axis. On the x-axis,
x-axis, no, 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 never. If you use 10, then it will cover only half of the graph. But our graph should be covering in both the axes more than half with the readings we have. Is it clear?
yes, sir.
So you should be careful about that. If you are not doing that, then you are losing 1 mark in scaling. Got it?
Yes, sir.
So 10, 20, this way go to 70. And after going there, you find the points. From the values given, you get the points, and after getting the points, you should draw curve line. You see, best they are saying, you see, in the question they are saying very important thing, best fit curve. So with your points, you will draw a smooth curve line. The line should be like this, smooth. I'm showing you little bit. You can also try it. After getting the points, it will be more clear to you. The graph will be like this. Okay, smooth curve. not discontinuous. It should be a smooth curve. Okay, is it clear? So do it and send the diagram in our group, messenger group.
Okay, sir.
With your pencil, you should draw this diagram with your pencil. Never use pen. Are you using pencil?
Yes, sir.
Yes,
Yeah,
sir.
of course you have to use pencil, and it is sharp pencil.
স্যার আমি শেষ করেছি, দিয়ে দিছি।
You have given, right? Let me check. Yes. So you have here the value of x. Let me check. Value of x starting from 15, right? Then 15 corresponding to 70. Yes. Then 20, 43. Okay, 44. Yes, correct. Then Abir, you also said, right?
Yes, sir.
Yes, correct. Yeah, both of your graph is correct, but you did not send me the unit of L. That is cut, right, in your image.
Yes, sir. In the photo.
Okay, okay, no problem. So during sending, you be careful, set the whole thing next time you are sending. Now we are having the next part. Two. Can you read it, Amir? Use your
graph to
right.
estimate the numbers n18 of rings required to balance the rule when L is 18. Show your workings clearly on your graph.
Okay, now you get it. Get it quickly by 2 minutes. So you got it? Hello?
Yes, sir. 48.
48 you got. And what about Abir?
Yes, sir. I also got 48.
You also got 48. Did you show it on the graph?
Yes, sir.
Okay, can you send it to me, both of you,
Yes, yes, sir.
the working? Are you sending? Yeah, you send it and join after 10 minutes, huh? Join after 10 minutes. Try the other part.
Okay, sir.
Okay, sir.